Briefly, what a split charger system is, why you have it, and how to build one. A split charge system is a way of charging both your starter battery and your leisure battery system. Firstly, why do we have different batteries for our vehicle's starter motor and leisure systems? The main reason is it's sensible. Why, you ask? Well, if you were to run down your starter battery, which can actually happen quite easily by, let's say, leaving a fridge turned on or a light or an entertainment system, and it was the only battery you had in your vehicle, you'd be stuck and you wouldn't be able to start your vehicle because, well, there was only one battery source of power used for everything. So it makes better sense to keep two separate power sources in the form of batteries, one exclusively for starting the vehicle, that being the starter battery, and another battery or body or group or bank of batteries exclusively for leisure purposes. The only time these batteries connecting with one another is when they're being charged up. Otherwise, we try to keep the starter battery and the leisure batteries electrically separated as best we can. So, how do we keep these batteries separated, yet also simultaneously charged up? There are several ways. However, one of the most common ways in a motor vehicle, such as a camper van, is to use the excess electric power that is created by the vehicle's motor or engine electric generating device, called an alternator, when the vehicle's motor is running. See my lesson number 1 to understand more about alternators. In brief, when your motor or engine is running, as well as giving your vehicle motion, your engine is also generating low voltage electricity via its alternator device. There are varying different sizes of alternator, some more heavy duty than others. By far and large, the majority of motor vehicle alternators create somewhere in the region of 13.5 to 14.5 volts of DC electricity at 40 amp and upwards. Heavy duty alternators on big engines, like fire engines and ambulances or cabin cruisers and motorized yachts, can create up to 300 amps, and there are some vehicles that have two alternators. However, an average motor vehicle alternator would create somewhere between 40 and 100 amps. See my earlier rudiments lessons for some basic knowledge on how amps, volts and watts fit into the electrical equation. So, some of this electrical power that is being created by a vehicle's motor goes into running the motor, like creating the electricity that is needed for the engine components, powering the lights and other things that require electricity in a regular running of a vehicle. However, whatever electricity that is being generated that is not being used by the vehicle when the engine is running is usually to be stored in the starter battery until that is the battery is full. The electricity generated 13.5 to 14.5 volts at roughly somewhere between 40 and 100 amps that is being sent to the starter battery charges the starter battery up and keeps it fully charged. However, when the starter battery is fully charged, the engine's alternator is still making electricity, which normally would just go to waste or is being burnt off in the way of heat via a regulator device. This is where our split charge system comes in. I'm going to try and make this as simple and straightforward as can be, without getting overly technical. A standard lead-acid starter battery, which is the most common type of vehicle battery as of 2023, has an electrical voltage when completely full of around 12.6 to 12.7 volts. As I've mentioned, the vehicle engine alternator creates an electrical charge of somewhere in the region of 13.5 to 14.5 volts. So, as we can see, the alternator is creating a slightly higher voltage than the battery. This slightly higher voltage is a good thing in this particular situation. The slightly higher voltage being generated by the alternator allows the electrical power to pour from the higher voltage alternator down to the lower voltage battery, because that's the nature of electricity. In this case, the higher alternator electricity voltage will pour into the lead acid starter battery. The lead acid starter battery cannot overfill. As soon as it's full, up to 12.6 or 12.7 volts, it just won't accept any more power. Just like when a glass is full of juice, it just flows right over the top of the glass. However, in this case, the overflow is addressed by the alternator's regulating device and burnt off, usually in the way of heat. When you turn your engine off, effectively also turning off the alternator from generating electricity, the power in the starter battery should sit at around 12.6 to 12.7 volts. Until that is, you use the power from the starter battery to start your vehicle. Starting your vehicle up might use a little bit of the starter battery's power, reducing its stored voltage down to 12.5 or 12.6 volts. But as soon as the vehicle is running again and the vehicle's alternator is generating power again, the starter battery's used power will be replenished and the alternator will take over powering the vehicle's electrics again with a 13.5 to 14.5 volts of electrical power. I won't go into the regulator factor built into many alternators, as this would only serve to confuse. But in short, excess power not going to the battery will be burnt off in the way of heat, and the power created by the alternator reduced. Now, you might have noticed that there were a few voltage differences in what I've just explained. A full lead-acid starter battery has 12.6 to 12.7 volts, and the alternator generates 13.5 to 14.5 volts. That difference being about 1 volt between the alternator and the battery voltages. This 1 volt difference between them is an important factor for the smart split charge system. A split charge system is like a switch, a clever switch, as it can sense when a voltage is higher or lower, higher being anything above 13.2 volts and lower being anything below 13.2 volts. Some split charge units have an adjuster knob or screw that can change or vary as to what voltage the split charge system considers lower and what voltage the split charge system considers higher. So, what does the split charge system switch? Well, it switches and allows the excess power that is running from the engine's alternator to the lead-acid battery to further travel on to the leisure battery, therefore charging the leisure battery as well as the starter battery. This usually being the case of when lead-acid leisure batteries are being used. When the vehicle's engine is turned off and the alternator is no longer creating the higher 13.5 to 14.5 volts, the split charge system senses the drop in voltage and disconnects the leisure battery from its connection to the starter battery circuit. Breaking that connection or circuit between the starter battery and the leisure battery ensures the two different purposed batteries don't get run down together should something in the leisure part of the vehicle be left on. Basically, when the engine's running, the two batteries are connected, and when the engine is turned off, the two batteries become isolated. However, if you run down your vehicle's starter battery down to nothing, you're going to be in some difficulty. However, if your leisure battery is run down and your starter battery is fine, then you can just start up your vehicle's engine and the alternator via the split charge system will recharge the leisure battery and hopefully all is well again. So how do we wire a split charge system in? Firstly, I'm going to explain how it's done on a vehicle using all lead-acid batteries. That is, normal lead-acid battery for the starter battery and a deep cycle lead-acid battery or lead-acid batteries for its leisure purposes. I will later explain a slightly more sophisticated and efficient system of battery charging from the alternator using a battery-to-battery charging device, sometimes referred to as a B2B or a DC-to-DC smart charging unit. These units being somewhat more expensive than the more common garden split charge systems, however they are more efficient and will charge lithium-ion leisure batteries also. Split charge systems are not so good for lithium-ion battery charging. However, let's get started on wiring up the more common and basic split charge system. I'm going to explain the most common way of wiring these systems. However, it's not the only way, but the way I have found them in other vehicles and wired them myself over the years. You will need to obtain a split charge device. As I said earlier, it's just a glorified switch that might fit into the palm of your hand, usually costing less than $50, pounds, euros. In short, it's kind of like two switches bound together. One little switch that in turn operates a big switch. Technically, that would be actually called a relay. Only the little switch gets switched when the voltage changes, and it in turn operates the big switch. The big switch is there because it can handle a lot more amperage or electrical power current racing through it. However, the little switch is a little too sensitive to handle a lot of electric power racing through it, so it passes the heavy lifting over to its bigger assistant. If they were husband and wife, the little wife switch is the smart one, and the big husband switch the strong one, but they both work together as a couple, that being the basics of a split charge unit. Using the same metaphor, when the small wife switch senses that the vehicle's engine is running and that the engine's alternator is generating more than 13.2 volts, it tells the big husband switch to allow electricity to run from the same electrical wire circuit as is charging the starter battery to further charge the leisure battery. When the vehicle's engine is turned off and the electrical power diminishes on the electrical circuit running to the starter battery from 13.2 volts down to the resting starter battery voltage of 12.6 or 12.7 volts, then the little switch senses the power drop and tells the big switch to cut the circuit between the batteries, therefore isolating the batteries from one another. So how do we wire in a split charge system? It's really not that difficult, but there are a few things we should check before we get started. Wire gauge is a rather important factor here. Split charge system you should locate anywhere near the starter battery or the leisure battery or somewhere in between, as there will be, hopefully red in colour, a cable or wire that is going to run from the starter battery positive, that's the red terminal, to the leisure battery positive, that's the red terminal also. However, this same wire somewhere between these two batteries will need to be cut and run through the split charge device. The device will also need an earth or ground wire. This should normally be a black wire and run from one of the starter battery's negative black pole or attached to the body of the vehicle if the vehicle vehicle that is negatively grounded, as many are. The wiring or cable used for the run from the battery onto the split charge system and then onto the leisure battery needs to be the right gauge. Always better to go heavier than lighter gauge, certainly for the positive red cable wire in this case. You're going to have to figure out how many electrical power amps are going to be traveling along this wire. You could probably get away with 5.2 millimeter squared or 10 AWG, which is American wire gauge, for a 3 to 6 foot run, or 1 or 2 meters of copper insulated red colored wire. The ground black wire can be the same or just a little lighter gauge than the red positive cable. This gauge of cable would serve a 100 amp hour 12 volt regular lead acid deep cycle leisure and starter battery system. If the amperages, voltage or lengths of wire needed are different to what I have given earlier, or you are using or planning on using a lithium ion battery, then you should consult one of the many free DC electric wire gauge and length calculators out there on the internet. The wire gauge really is important, as if you use too light a wire gauge, it can work poorly and also be a fire hazard. I can't stress the importance of wire gauge more. So that's pretty much all there is to installing a split charge system. Just a note to keep in mind, again, if you're considering a lithium ion battery for your leisure battery, then you should use heavier wiring and a B2B or DC to DC charging device instead of a split charge system. More on this in the next tutorial. Also, I will cover wire lugs and heat shrink sleeving. A couple of other things are you're going to need fuses on either side of the split charge device. These fuses or breakers should always be just a little below your wire gauge grade in amps. So if you're using 100 amp wire gauge grade, which I mentioned earlier, 5.2 millimeters squared or 10 American wire gauge AWG, then you would probably want a breaker fuse at 100 amps rating or a little bit less. You would want to put these breakers or fuses on either side of the split charge system. So on the wire that leads to the starter battery, you'd want one of these breaker fuses, and on the wire that runs to the leisure battery, you'd want a breaker or fuse, be it 90 amps or 100 amps on what I suggested earlier, being the 5.2 millimeter squared or 10 AWG wire.